Hello guys, in this video we'll discuss about NumPy, which is a Python library, and I'll try to cover most of the concepts. First, let us understand what is NumPy. NumPy is a Python library and we all know that it is open source. Anyone can use it for free. NumPy stands for Numerical Python and it is used for working with arrays. If you know any programming language like C, C++, or Java, you will be familiar with arrays. Arrays store multiple values of same data type in single variable. I'll show you a one-dimensional array. This is one-dimensional array. Here, the elements are stored in continuous memory locations. We will discuss about types of arrays further. NumPy was created in 2005 by Travis Oliphant. Now the question is, why to use NumPy? In Python, we have lists, but we choose arrays over lists because arrays are 50 times faster than the lists. Because in arrays, the elements are stored in continuous place, continuous place in the memory, so we can access and manipulate them very easily. Here, the NumPy creates array object, which is called as ND-array. Now let us see the installation and importing of NumPy. To use the functions in NumPy, first we need to install it in our system and we need to import it into our code. First, let us see the installation of NumPy. Just open your terminal or command prompt. Copy the path where you stored the Python and in terminal just write cd and paste that path. This will help us to change the directory and then write this statement pip install numpy. This will install the numpy library in our system, and I always prefer Jupyter notebook because some of the libraries are installed defaultly and it's all up to you. And next thing is importing numpy. To use that in our code, we need to import numpy into our code. Importing is very easy. Just write import numpy at the beginning of the code. Instead of writing numpy everywhere in the program, you can also write with alias name with as keyword. Here the alias name is np. Instead of writing np everywhere, you can write np. This is about installation and importing numpy. To check the version of numpy, first import the numpy. After installation, write import numpy as np, and then with version attribute we can find the version of the numpy in our system, np dot underscore underscore version underscore underscore. This will give the version of numpy in our system. You can also print that on your screen. This is about introduction, installation and importing numpy. Thank you for watching. See you in the next video. Hello guys, in this video we will discuss how to create and initialize NumPy arrays. First, let us see the easiest method to create an array. It is done by using array function. We can pass a list, tuple or any array-like object into the array method and that will be automatically converted into an ND array object. See the example here. Array is equals to np.array of 1, 2, 3, 4, 5. Here this 1, 2, 3, 4, 5 is a list and this arr is a variable in which we are going to store the array elements. Generally, when we are accessing any function from an library like NumPy, we need to write NumPy dot and that function name. In most of the cases, we import NumPy as np with alias name. So here I wrote np dot array of 1, 2, 3, 4, 5. This also can be written as np dot array of 1, 2, 3, 4, 5. This is a tuple. This can also be written like this. We saw how to create an array. Now let us see the different types of arrays. First one is zero dimensional arrays. Zero dimensional arrays. They are simply scalars. They contain only a single value. Array is equals to np dot array of 42. Another example is np dot array of 35. This is also an example of zero dimensional array. Next one is one dimensional array. An array that has zero dimensional arrays as its elements is called one dimensional array. It is simply a combination of zero dimensional arrays. See the example. ARR is equals to np dot array of 1, 2, 3, 4, 5. Here 1 itself is a zero dimensional array and 2 itself is a zero dimensional array. It is simply the combination of zero dimensional arrays. So it is a one dimensional array. Next one is two dimensional arrays. Array that has one dimensional arrays as its elements is called a two dimensional arrays. It is simply a combination of one dimensional array. See the example. ARR is equals to np dot array of 1, 2, 3, this is a list, and 4, 5, 6, this is a list. This is one dimensional array and this is also a one dimensional array. It is a combination of one dimensional array. So this is a two dimensional array. We need to enclose this in another braces. Next one is three dimensional arrays. An array that has two dimensional arrays as its elements is called a three dimensional array. Simply it is a combination of two dimensional arrays. In previous example we saw that 1, 2, 3, 4, 5, 6, this is a two dimensional array, and this part is also a two dimensional array, and it's a combination of two dimensional array, so it is a three dimensional array, and we need to enclose this in another braces. This is about types of arrays. Now let us see some other methods to create an array. First one is by using zeros function. It returns a new array of given shape and data type but with zeros. It generates a new array which contains zeros and the size is given by us. I will show you the syntax of this function. NumPy dot zeros of shape comma d type is equals to float. Here shape is the size, I mean the dimension of the array, and data type is the type of data which you want to store in that array. Defaultly the data type is float. To understand this much clearly, I will show you in my Jupyter notebook. Here I created a new file. To use NumPy, first we need to import it. So import NumPy as np. I am creating an array with zeros function np dot zeros of, I'm giving shape as 3. Now I'll print it. Here I got an array of size 3 and the data type of elements is float because it is the default data type. If you want to change it, you need to specify it in the parameters. Now I'll give the shape as 7. Again I'll print it. Here I got an array with size 7 and the data type is float. Now I'll specify the data type 7 comma d type is equals to int. Now I'll print it. Here I got an array of size 7 and the data type is integer. In the same way, I can create an array with different size, zeros of 2 comma 3. Now it will give an array with 2 rows and 3 columns. I'll print it. Yeah. Here we got 2 rows and 3 columns. And again here I can specify the data type np dot zeros of 2 comma 3 comma d type is equals to int. Yeah. Here I got 2 rows and 3 columns, and the data type is int. This is about zeros function. Next one is full method. It creates a new array of given shape and data type, but with a given fill value, not with zeros as seen before. Syntax is numpy dot full of shape, fill value, and data type. I'll show in my Jupyter notebook. First, I will import numpy as np. Now I'll create an array np dot full of, and the size is 2, and the value I want to fill is 10.25. Now I'll print it. Here I got an array of size 2 and the value is 10.25. I'll show you another example. np dot full of size is 2 comma 5, that is 2 rows and 5 columns, and the value is 10. I'll print. Yeah, here I got 2 rows with 5 columns and the value is 10. Now I'll change the data type. np dot full of 2 comma 5, and the value I want to fill is 11.5, and the d type I want is int. Yeah, the value here I given is 11.5, but it only takes 11 because I specify the data type as int. This is about full function. Next one is random.rand function. It creates an array of specified shapes, but it fills with random values between 0 and 1. Here the only parameter you need to give is the shape. I'll write the syntax. numpy dot random dot rand of shape. This is the syntax. First import numpy. Import numpy as np. I'll create an array. Array is equals to np dot random dot rand of. I'll give size as 7. I'll print the array. Yeah. Here I got an array of size 7 and the values are some random values between 0 and 1. I'll show another example. np dot random dot rand of 5 comma 7. Yeah. Here I got an array with 5 rows and 7 columns, and the values are some random values between 0 and 1. This is about random.rand function. Next one is once function. It creates a new array of given shape and data type but filled with ones. It is same as zeros function. Instead of zeros, we have ones in the array. Syntax is similar to zeros function. numpy dot ones of shape and d type. Defaultly, the data type is float. I will show you in Jupyter notebook. First, we need to import numpy. import numpy as np. I'll create an array np dot ones of, and the size I want to give is 8. I'll print it. Here I got an array of size 8 and the data type is float because the default data type is float. I'll show you another example. np dot ones of, here I'll give size as 3 comma 5, 3 rows and 5 columns, and the data type is int. I'll print the array. Here I got an array of 3 rows and 5 columns and the data type is int. I'll show another example. Ones of 2 comma 3. Here I did not specify any data type. So the data type is float. Let's check it. Yeah. Here I got an array with 2 rows and 3 columns and the data type is float. This is about ones function. Next one is I function. It creates a 2D array with ones as the diagonal and zeros elsewhere. Syntax is numpy dot I of rows comma data type. It always creates a square matrix, so no need to specify columns, just rows is enough. I will show you in Jupyter. First import numpy. Import numpy as np. I'll create an array np dot I of, and the rows I want to give is 2. Now I'll print it. Let's see the output. This is a square matrix. I mean, it is also a diagonal matrix. The diagonal elements are 1 and the remaining elements are 0. And the data type is float. I'll show another example. np dot I of 5. And the d type is int. I'll print it. This is a diagonal matrix of rows 5 and columns 5. And the data type is int. This is about I function. Next one is arrange function. It creates an array with evenly spaced elements as per the interval. Syntax is numpy dot arrange of start, stop, step, and data type. Here start is the start value of the interval range and stop is the end value of the interval range. It is exclusive, and step is the step size of the interval. Step can't be 0, otherwise you will get a 0 division error. I'll show you in Jupyter Notebook. First, we need to import NumPy. Import NumPy as np. I'll create an array np dot arrange of 4 comma 20 comma 3. Here 4 is the start value, 20 is the stop value, and 3 is the step size. I'll print the array. Here we got a new array of evenly spaced integers between 4 and 20, and the step size is 3. We will not include the last element. The last element is exclusive. I'll show you another example. np dot arrange of 5 comma, and the stop value is 100, and the step value is 10. I'll print the array. We got a new array between 5 and 100 and the step size is 10. What if I only give a single value? Let us check. Here I given only a single value instead of start, stop and step. Here we got 0, 1, 2, 3, 4. If you give only a single value, it is considered as stop value, and the start value becomes 0 and the step count will be 1. Step count should not be 0, otherwise it gives a division by 0 error. What if I give only two parameters? Let us check. I'll give 5 and then 10. Guess the output. The output will be 5, 6, 7, 8, 9 because 5 is considered as the start value and 10 is considered as the stop value, and the step count will be 1. Output is 5, 6, 7, 8, 9. This is about arrange function. This is widely used function in machine learning. Next one is line space function. It returns an array of evenly spaced values within the specified interval. It is similar to the arrange function, but it doesn't allow us to specify the step count in the syntax. Instead of that, it only returns evenly spaced separated values over a specified period. It implicitly calculates the step size. I'll write the syntax numpy dot line space start stop num and end point. Here start represents the starting value and stop represents the ending value. And here num is the amount of evenly spaced samples over the interval to be generated. The default value is 50, and endpoint can be true or false. If it is true, it indicates that the stopping value is included in the interval. If it is false, it indicates that the stopping value is excluded in the interval. I'll show you in Jupyter notebook. First, we need to import NumPy. Import NumPy as NP. I'll create an array np dot line space 10. 10 is the start value, 100 is the stop value, and 10 is the num. That is, I want 10 elements between 10 and 100. I'll print the array. We got 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Here 100 is also included because endpoint is set to true defaultly. For the same example, I'll change the endpoint to false and then we'll see the output. np dot line space 10, 100, and I want 10 elements, and the endpoint is set to false. Now let's see the output. Sorry, I forgot to print array. I got 10, 19, 28, 37, 46, 55, 64, 73, 82, 91. Here 100 is not included and the elements are evenly spaced between the interval 10 and 100. This is about line space function. Next one is log space method. It creates an array with evenly spaced numbers on a logarithm scale. Its syntax is numpy dot log space start stop num endpoint and base. It is much similar to line space. Here start is the start value of the sequence, stop is the end value, and num is the number of samples we need to generate, and endpoint we already seen this before, and base is the base of log scale. We need to import numpy. Import numpy as np. I'll create an array np dot log space 10 is the start value, 20 is the stop value, and the number of samples I want to generate is 5, and I'll set the endpoint to true. I'll print the output. This is the output. The range of the output is between 10 and 20. 20 is also included because endpoint is set to true. Here I did not mention any base value, so the default base value is 10. I'll show you another example. np dot log space, start value is 10, stop value is 20, and the number of samples is 5, and endpoint is true. Now I'll set base value as 2. Now we will see the output. This is the output with base 10, and this is the output with base 2. These are the various methods to create and initialize arrays in NumPy. Thank you for watching. See you in the next video. Bye bye. Hello guys, in this video we will discuss about NumPy arrays indexing and slicing. Coming to indexing, indexing is nothing but accessing an array element. We access an array element by its index number. Generally, index starts with 0. See the example here. This is a one-dimensional array and 7 is the first element, so it has index 0, and then 2 has index 1, and then 2, and then 3. If you want to get 9, then you need to write array of 2 because 9 is located at index 2, and here simply I am assuming the array name as ARR. See this example. This is a two-dimensional array. Here we have rows and columns. So the first row's index number is 0, and for the second row the index number is 1, and for the first column the index number is 0, and for the second column the index number is 1, and for the third column the index number is 2. If you want to access this element 3.0, then you need to write array of, first you need to specify the rows index number, that is 0, and then columns index number, that is 1. This will give you 3.0. In the same way, if you want to get this element 0.3, then you need to write array of first rows index number, that is 1, and then column index number, that is 2. In the same way, we can access three-dimensional arrays. Let us see some examples in Jupyter. First, we need to import NumPy. Import NumPy as np. Now I'll create an array. First, let us see one-dimensional arrays. Array of 1, 3, 7, 5, 23. This is a one-dimensional array. Now I want to print the first element. Then I need to write array of 0 because the first element's index number is 0. Let us run the code. We got the output 1 because 1 is located at index 0. What if I want to print 5? Let us find out the index number of 5. 1 has index 0, 3 has index 1, 7 has index 2, so 5 has index 3. Array of 3. We got 5 because 5 is located at index 3. What if I write array of 10? Here we have only 5 elements, so the last element's index is 4. Here 10 is out of bound. Let us see what will be the output. We got an error. Index error. Index 10 is out of bound. If you want to access any element that is out of range, it will show you error. Now let us create a two-dimensional array. np dot array of 1, 2, 3, 4, 5, and 6, 7, 8, 9, 10. This is a two-dimensional array. Now I want to print this element 5. I already told you first we need to specify row index number and then the column index number. This is first row, so the index number will be 0, that is array of 0, comma. Now we need to specify column index number. One has column index number 0, and here 1, this is 2, and this is 3, and this is 4. So 5 has column index number 4. Let us print the output. We got 5. In the same way, if you want to print this 8, this is in the second row. That is, the index number will be 1, and then the column index number. This is 0, this is 1, and this is 2. So 2. We got 8. This is about two-dimensional. Now let us create a three-dimensional array. np.array of, this is a three-dimensional array because it is a combination of two-dimensional arrays. Now I'll print element at 0, 1, 2. Let us see the output. We got 5 because here the 0 indicates this two-dimensional array, and then 1 indicates this list, and the index of this list will be 0, and again in this the 3 has index 0, and 4 has index 1, and 5 has index 2. So we got 5. Now I want to print this 6. Simply write array of, this list has index 1, so 1 comma, and then this nested list has index 0, so 0, and then 6 has index 2. Yeah, we got 6. This is about indexing.
Now the next topic is slicing. Slicing in Python means taking elements from one given index to another given index. It allows us to extract a portion of an array by specifying the range of indices. Either we can extract some part of the array or the entire array. Syntax of slicing is start is to end is to step. We can write it as array of start is to end is to step, where start is the starting index and end is the ending index. Let us assume that ending index is n. Then it considers the elements up to n minus 1. It ignores the nth element. And step is nothing but the step size between each element in this slice. Let us go to Jupyter Notebook. After seeing some examples, you will understand. First, we need to import NumPy. Import NumPy as NP. I'll create a one-dimensional array. NP dot array of 10, 20, 30, 40, 50. This is a one-dimensional array. Now I'll create a variable slice1. Here I want to extract only this part, that is 20, 30, 40. So starting index starts from here, that is index of 20 is 1. So 1 is 2, and the ending index I need to print up to 40. So I need to write 1 plus 1, that is 40's index is 3. I need to write 3 plus 1, that is 4. And step size I am keeping it as 1. Defaultly step size is 1. I'll print this slice 1. We got 20, 30, 40. There are three important points to remember. That is, if we don't pass start index, then it will consider the start index as 0. And if we don't pass the end index, it will consider the length of array in the dimension. And if we don't pass step, it is considered as 1. Defaultly, the step is 1. Again, I am repeating the points. If we don't consider the start index, it is considered as 0. And if we don't pass the end index, it is considered as the length of the array. And if we don't pass this step, it is considered as 1. Let us see another example. Array 2 is equals to np dot array of 20, 33, 45, 8, 77, 62, 99, 23. This is also a one-dimensional array. Now in slice 2, I want to extract from here to here. That is from 77, 99. I want 77, 62, 99 in my slice 2. So starting index will be, this is 0, this is 1, this is 2, this is 3, this is 4. So starting index will be 4, and this will be 5, and this will be 6. Last element index is 6. So we need to write 6 plus 1, that is 7. And step size is, I'm keeping here again 1. Let us run this. Print slice 2. We got 77, 62, 99. Now for this example, I'll give step size as 2. Let us see what it will print. Slice 3 is equals to array of starting index is 0, and I don't want to give the end index, so it will take the array length, and the step size is 2. I'll print slice 3. Let us see the output. We got 10, 30, 50. It starts from the first index 10. Step size is 2, so it skips 20, and then it will go to 30. It will print 30, and it skips 40 because the step size is 2, and the last index is, and the last element is 50. There is another concept called slicing with negative indices. Negative indices are used to slice from the end of the array. We'll see example on this array. I'll name it as slice 4, array 2 of -3 is to. According to our assumption, this will print the last 3 elements because the negative inverse starts taking elements from the end of the array. Let us see. I'll print the slice 4. Yeah, we got last 3 elements 62, 99, 23. If I want the last 5 elements, then array 2 of -5 will print this slice 5. Yeah, we got the last 5 elements 8, 77, 62, 99, 23. This is about negative indices slicing. Now let us see another example on two-dimensional array. np dot array of. Generally, two-dimensional array is a combination of one-dimensional arrays. This is a two-dimensional array. Now I'll name it as slice 6 is equals to. Now I want to extract subarray from row 1 to 2 and column 0 to 2. That is, this is row 0, and this is row 1, and this is row 2. And in the same way, this is column 0 in all the 3 lists, and this is column 1, in all the list, and this is column 2 in all the list. Now I want array 3 of 1 is to 3, comma 0 is to 2. That is row 1 to 2, that and column 0 to 2. Now I'll print this slide 6. We got 4, 5, 7, 8. Row 1 is to 3 means this is the row 1, this is the row 2. Simply we'll ignore the third row. There is no third row. And this is column, that is 4, 5. We'll ignore this part. And 7, 8. We'll ignore 9. So we'll print 4, 5, 7, 8. This is about slicing. Hello guys, in this video we will explore some common NumPy array attributes. First of all, what is an attribute? Attributes are properties of NumPy array which provides information such as shape, size, data type of the array. First we'll see all the attributes briefly and then we'll move on to the Jupyter notebook. First one is NDIM. It returns the number of dimensions of the array. That is, it tells whether it's a one-dimensional array or two-dimensional array or three-dimensional array. And the next one is size attribute. The size attribute returns the number of elements in the array. We can understand by the definition itself. And the D type attribute. It returns the data type of elements in the array. And the shape attribute. It returns the size of the array in each dimension. That is, it tells how many rows and columns are present in the array. And the next one is item size. It returns the size of each element in the array. And the last one is data. It returns the buffer containing actual elements of the array in the memory. After seeing examples, you'll get clarity on this. Let us go on to Jupyter Notebook. Now, the first attribute is NDIM. First, let us import NumPy. Import NumPy as NP, and then I'll create an array. Array1 is equals to NP dot array of. I'll create a two-dimensional array. 2 comma 4 comma 6, and then 1 comma 3 comma 5. This is the two-dimensional array. Now let us print the dimension of the array. Array1 dot NDIM. We got 2. Thus this is a two-dimensional array. Now I'll write another example. NP dot array of 1 comma 2 comma 3. Now again I'll print the dimension of array2 dot NDIM. Let us see the output. We got 1. This is a one-dimensional array. And the next one is size attribute. Size attribute returns the total number of elements in the array. For the same example, array1, I'll just print the number of elements, that is array1 dot size. We got 6. That is, we have 6 elements in this array. And for the second example, array2 dot size, let us see the output. We got 3. That is, there are 3 elements in the array. This is about size attribute. And the third one is shape attribute. It returns a tuple that gives the size of the array in each dimension. That is, it gives number of rows and number of columns in the array. For this example, we have 2 rows. This is first row, and this is second row, and this is first column in all the list, and this is second column, and this is third column in all the list. We need to get 2 comma 3. Let us see the output. Array1 dot shape. Yeah, we got 2 comma 3. That is, we have 2 rows and 3 columns. And the fourth one is dtype attribute. It helps us check the data type of the array elements. We'll use the same example, print of array1 dot dtype. We got in 32. That is, in this case, the data type of elements in array1 is in 32. And the next one is item size attribute. It returns the size of each element in the array. I'll use another example for this. Array3 is equals to np dot array of 6 comma 7 comma 8, and array4 is equals to np dot array of 6 comma 7 comma 8. But here I am mentioning d type is equals to in 64. Now I'll print the item size of both arrays. Array3 dot item size and array4 dot item size. Let us see the output. Sorry. I need to keep np dot int 60. We got 4 and 8. Here, array 3 has 32-bit integers. So each element takes 4 bytes. And the array 4 has 64-bit integers we mentioned here. So it takes 8 bytes. And the last one is data attribute. It returns the buffer containing the actual data of the array stored in the memory. I'll show you with an example. Um, I'll use the previous examples. Array 3 dot data, and I'll use the first array 1 dot data. Let us see the output. This attributes points to the memory address where the actual elements of the array are stored. And this is about NumPy array attributes. Thank you for watching. Hello guys, in this video we'll focus on two things. First one is arithmetic array operations and the second thing is statistical functions. Coming to arithmetic array operations, we can perform element-wise arithmetic operations directly on the arrays. Here are the main operations and we'll see how they work. First one is addition. It adds elements of two arrays. For example, I have an array as 1, 2, 3 and another array as 4, 5, 6. I want to perform addition on this. As a result, I'll get 5, 7, 9. Simply, this is the addition of two arrays. We can use this operator or the function. We'll see the examples on the Jupyter notebook. And the second one is subtraction. Simply will perform subtraction on the two arrays. In the same way, for multiplication, we'll multiplicate the two arrays. And for the division, we'll divide those two arrays. And coming to exponentiation, we raise each element in an array to the specified power. After seeing examples, we'll get clarity on this. And the last one is modulus. We'll perform modular division on the two arrays. Let us see the examples on Jupyter Notebook. First, we need to import NumPy. Import NumPy as NP. I'll create two arrays. NP dot array of the first array has elements 1, 2, 3. And the second array has elements 4, 5, 6. These are the two arrays on which we are going to perform all the operations. First, we'll see the addition. Print array 1 plus array 2. Yeah, we got 5, 7, 9, which is the correct output. And this is by using operator. Now we'll see by function np dot add of array 1 comma array 2. We got the same output. Now we'll see the subtraction. Print of array 1 minus array 2 and print of np dot frac of array 1 comma array 2. Yeah, we got the same output for both the operator and the function. Now we'll see the multiplication. Print of array 1 into array 2 and again print of np dot multiply of array 1 comma array 2. We got the correct output. And again, now with the division, array 1 by array 2 and with function np dot divide of array 1 comma array 2. Yeah, we got the correct output. Now for the exponentiation, that is print of array 1 power 2. This is by using operator. Now by using function, that is np dot power of array 1 comma 2. We got the squares of the array 1. Array 1 has elements 1, 2, 3, and square of 1 is 1, square of 2 is 4, and square of 3 is 9. We got 149 by using both operator and function. And the last one is modular division. It returns the remainder of the element-wise division. Let us see the example. Print of array 1 percentile 2. We got 101. Array 1 has elements 1, 2, 3. First element is 1. 1 is divided with 2 and the remainder will be 1. And 2 is divided by 2 and the remainder will be 0. And 3 is divided by 2 and the remainder will be 1. We got 101. Now by using function, that is print of np dot mod of array 1 comma 2. We'll get the same output. Yeah, 101. This is about arithmetic array operations. Now coming to statistical functions. First one is median. That is, it returns the median of an array, that is the middle element. And the second one is mean. It returns the mean of an array, that is the average of the elements of the array. And the third one is standard deviation. It returns the standard deviation of the array. And the fourth one is percentile. It returns the nth percentile of elements. And the fifth one is min function. It returns the minimum element of the array. And the last one is max function. It returns the maximum element of an array. Let us see the examples on Jupyter. See some examples on statistical functions. First one is median. We already know that median is the middle value in a sorted array. We'll just see the example. np dot median of array 1. This is array 1. Array 1 has elements 1, 2, 3 and the middle element is 2. So the output should be 2. Let us see the output. We got 2. This is about median. Now we'll find the mean of the array 1, that is np dot mean of array 1. Mean of array 1 is 2. In the same way, we calculate the mean of array 2. np dot mean of array 2. We got 5. Average of 4, 5, 6 is 5. And the next one is standard deviation. It measures the spread of array values from the mean. I'll simply print it. np dot std, which stands for standard deviation of array 1. We got 0.8164 something. This is about standard deviation. And the next one is finding maximum element. That is, we'll use np dot max of array 1. It returns the maximum element in the array 1, which is 3. And in the same way, I'll use the min function, which returns the minimum element in the array, which is 1. Max function returns the maximum element in the array, and the min function returns the minimum element in the array. And the last one is percentiles. They are useful for understanding the relative standing of elements in the data set. Let me give an example. The 50th percentile indicates the middle value in the data, and other percentiles like 25th, 75th, they represent the first and third quartiles. I'll take another example for this. That is, array 3 is equals to np dot array of 1, 3, 5, 7, 9. Now I'll bring the percentile of the 50th percentile. That is np dot percentile of array 3, comma 50. I want 50th percentile. We got 5. In the same way, I'll print the 25th percentile. That is print np dot percentile array 3 comma 25. I got 3 because 3 is the 25th percentile. This is about statistical functions. Thank you for watching.